Okay, so I'm going to record this video for your quiz tomorrow. Just going to use it in this view so that I can switch back and forth between the notebook and the presentation on Google Slides. These are very similar problems to what you're going to see tomorrow on your quiz. Number one, what's the molar mass? So be able to find the molar mass of a substance. We have Na2O. So for Na2O, what we're going to do here is you just take what's in it. So Na2O, that consists of 2 sodiums and 1 oxygen. So Na 2 times 2 of those, and oxygen, there are just 1 of those atoms in this molecule. So when we're doing molar mass, we use the values given on the periodic table for atomic mass. And so for sodium, it says the mass is 22.99. So when I find the overall mass, I'm going to be using 2 times that because there are 2 atoms. And then oxygen is just going to be 16.00 grams. So if I have 2 sodiums at 22.99, that's going to give me 45.98 grams, I believe. And then 1 times 16, of course, is just going to be 16 grams. And this would give me an overall mass for this molecule of 61.98 grams. That is how many grams are in 1 mole. Okay. Our next problem, we have 200 grams of MgCl2. How many moles would this be? All right. Come back to this again. MgCl2, and we have 200 grams of it. How many moles? That's the question. So like I told you guys, whenever you do these problems, start with what's given. So they're telling us that there are 200 grams of MgCl2. And you always just put that over 1, never any units for the start, okay? I forgot my grams, all right? And that's important that I know what unit that is here because that's what determines what goes down here. And so if I think about this, they're telling me I have 200 grams. They want me to find out how many moles they have. So really what I'm going to try to do, what I need to think about is how many grams make up 1 mole. Because then I can use that as a comparison to try to figure out how many moles I have or how many grams I have in these problems. So I'm definitely going to need to find out how many grams are in 1 mole of this. So MgCl2 molar mass, I have Mg and I have 2 Cl's. So I turn to my periodic table again, and Mg has a mass of 24.31 grams. And then I have 2 chlorines. 35.45 is their mass. Okay. And then I need to add those up. So I have 24.31 plus 35.45 plus 35.45. So the mass of 1 mole of this stuff would be 95.21. All right. Okay, so I know there's that many grams per mole. It's another way of writing molar mass like that. And I know the grams should go on the bottom down here. So I'm going to put it down here, 95.21. That's a 5, sorry. Per 1 mole. And the grams cancel out. So what this shows me is really what I'm ending up with is a division problem. So on the top, I'm just going to have 200 moles of MgCl2. And on the bottom, I'm going to have 95.21. So I'm going to take 200 divided by 95.21, and I'm going to get 2.1. So there are 2.1 moles. And that's your answer. I mean, you can think about these as just, hey, if I have to go from grams to moles, I just divide by the molar mass. If I have to go the other way, I multiply by the molar mass. But that can get really confusing. It's nice to be able to set up these problems so that the units cancel out. Works really good, shows you how to go. All right, so the next question. 2.5 moles of K, what would be the mass? 2.5 moles of K, what would be the mass? Now on the quiz, it might not be this easy, just using an element. I could use a compound, but so I'm writing down what they told me, keeping in mind that I got to find the mass, okay? So I know I have 2.5 moles of K. I do know that I can find the mass of 1 mole by looking at the periodic table. And it's really easy to do for K because it's just an element. All I got to do is look at what is the mass of K, and it's 39.10 grams per mole. Okay? Now, if I see what starts here, I know that that's got to go down here. And so if moles are on the bottom, that's how they are over here too. So I'm just going to write my molar mass the way it is. And if I think about it, it makes sense that if 39.10 grams is the mass of 1 mole of K, and I have 2.5 moles, I would just multiply the molar mass by 2.5, which is essentially what we're doing here. All right. So we got 2.5 times 39.1, and I get an answer of 97.75. And the units I have left are grams, and there's my answer. Okay. All right, so the next question. I have how many atoms would be in 20 grams of lithium? How many atoms? That's what we're trying to find. That's our goal. And we have 20 grams of lithium. So this tells me what I actually have. I'm going to start with that. So 20.0 grams of Li over 1. And again, I see grams there. That means grams have to go on the bottom. All right. So if we're going to find the number of atoms, and all I know is the mass, I don't know any relationship for everything between mass and atoms. But what I do know I can find is if I know the mass of a substance, I can use its atomic mass to make its molar mass, and then I can find out how many moles I have. So for example, I look at the periodic table, and it tells me there are 6.9 grams of lithium per mole. So if I do this, I'm going to find out how many moles I have, and that's going to give me some answer. Now I can stop there and find that answer and move on, or I can even just keep going. All right. So if this tells me how many moles I have, then all I have to do from there is multiply by Avogadro's number. So see if this makes sense too. I know I'm dealing with an element, 6.02 times 10 to the 23rd atoms of lithium for every 1 mole. And look, the moles cancel out also, okay? So now setting this up so that my units all cancel properly, and then looking at the unit I have left, and seeing that it's what I'm looking for, I know that I have the proper equation here. So what I'm going to do here is I'm just going to multiply straight across the top, and that's going to give me kind of a long answer, so I'm going to write it down here, but I'm going to get a top answer, I'm going to get a bottom answer. I can see the bottom answer is really easy, it's just 6.9. But on the top, it's a little trickier. I have a regular number times scientific notation. And I always think of the scientific notation normal part and then the times 10 part here. All right. So just multiply the normal part, 20 times 6.02. $120.4. All right. Don't forget the times 10 part. All right. Now we have a division problem. Same thing, I'm going to take my normal number on the bottom, and I'm going to use this normal part of the scientific notation. I'm going to take 120.4, and I'm going to divide by 6.9. My answer comes out to be 17.45. And again, we can't forget the times 10 to the 23rd part. So that's how many atoms I would have of lithium for that mass, 20 grams. This is not really correct scientific notation. I should move this decimal 1 to the left to make a number between 1 and 10 and compensate with the exponent. So if I make that 1 spot smaller, make your exponent 1 spot bigger. And it's atoms of lithium. And that's your answer. Okay, so next problem. That was one of the longer ones there. What would be, oh, well, this is kind of a long one too. What would be the mass of 1.806 times 10 to the 24th molecules of H2O? So that's what I want to know. I want to find the mass. So I want to find the number of grams. Okay. So I'm going to put this over 1. And the first thing I want to do is find out how many moles that would be. All right. So I've got molecules here. Molecules go here. Okay. And if I'm converting between molecules and moles, then I'm going to use the Avogadro's number. And that's got to go down here because that's telling me the number of molecules in a mole. All right. And if I do this, if I just stopped right here, broke this up into a separate problem, I could continue like I did on the last problem. But if you take 1.806 and well, let's just see what this comes out to be. The molecules have canceled out. I've got moles. So what we do on these when we have two numbers that are scientific notation is divide the front number normally, which comes out to be 0.3, write times 10, and subtract the exponents. 24 minus 23 is 1. So there's my answer. Really, what this is just saying 3 moles. 0.3 times 10 to the first, 3 moles. So if I have 3 moles of water, how many grams would that be? Oops. So I know that the mass, the molar mass of H2O, 2 hydrogens and 1 oxygen, if I add them all up, there are 18.02 grams according to our periodic table. That's 2 H's added to 1 O and 1 mole. So really it's just a multiplication, 3 times 18.02, and that's going to come out to be 56.04 grams. All right, empirical formula. So the molecular formula tells you the type of atoms that are in it and the number of each. That's the molecular formula, though. The empirical formula tells you to just look at what's in it and make the simplest ratio. So the molecular formula here, there's 4 C's, so it'd be C4, and H, there are 6 of them, okay? That's the actual molecular formula. It tells you what's in it, carbon and hydrogen. It tells you how many of them there are. So if I just compare these, it's a 4 to 6 ratio between carbon and hydrogen, okay? But that's not what it's asking. In empirical formulas, what we do is we take that molecular formula that we have and we look for the simplest whole number ratios between the two things. So if I'm looking at two numbers, or a number that goes into both of these evenly, I know one does, but I got to find something besides that. So 2 goes into both of them, 3 doesn't, 4 doesn't. So what I'm going to do is I'm just going to take both of these and divide them by 2 to simplify them. So the empirical formula for this compound would be C2H3, and that's your empirical formula. All right. Now we get a little bit different problem. This is finding empirical formula from percentages. So I have 25.9% nitrogen. 25.9. And I have 74.1% oxygen. All right. So the first thing we do is just assume that we have 100 grams of this substance. Because if we had 100 grams, that makes it easy to figure out how many grams of each I would have. If I have 100 grams total, then 25.9 grams of that would be nitrogen, and 74.1 grams would be oxygen. Okay? And I'm going to use these values to do my work. What we're going to be trying to figure out in terms of making an empirical formula is look for the number of moles. So if I have 25.9 grams of nitrogen, how many moles of nitrogen do I have? Well, if I look at the periodic table, I see that nitrogen has a mass of 14.01. So that means if I take 25.9 and I divide by 14.01, I get 1.85. Okay. So I have 1.85 moles of nitrogen. Oxygen, I have 74.1 grams. So it looks like I'm going to be dividing by the molar mass of oxygen, which according to the periodic table, 16 grams per mole. So I'm going to get 74.1 over 16. 4.63. All right. So I'm trying to figure out the simplest whole number ratio between these two things. So right now what I've got is it looks like my ratio of N to O is like 1.85 to 4.63. All right. Though empirical formulas have to have the simplest whole number ratio. So right away I see These are not whole numbers. So I got to try to figure out how to get them to be whole numbers. Well, I can guarantee I have at least one whole number if I just take the smaller number of the two, which is this one, and divide both numbers by that. Okay, so now my n is going to be 1, okay, and my O is going to come out to be 4.63 divided by 1.85. I'm just looking for a round number, about 2.5. Okay, so that's helpful because now I can see that this ratio I had over here, this 1.85 to 4.63, is the same thing as a 1 to 2.5 ratio. Now, still not quite good enough because this is not a whole number, it's 2.5. So at this point, what you want to start doing is doubling the subscripts, tripling them, multiplying them by 4, 5, 6, whatever, until you get something that works out and gives you whole numbers. If I start off by doubling both of these, that means n instead of 1 would have 2, and O instead of being 2.5 would have 5. And look at that, just doubling them, we got whole number subscripts. That works. Can't break it down any further. 2 to 5 ratio is the smallest it goes without getting decimals. So that is our empirical formula. Now, in the next question on the review, is I use that N2O5. I say, what would be the molecular formula for a compound that has an empirical formula of N2O5 and a molar mass of 236.04 grams? All right, so the empirical formula is just the simplest ratio. We know this. All right, it's not the actual compound, okay? It's not saying that the compound necessarily has 2 nitrogens and 5 oxygens. It's just saying that the ratio of nitrogen to oxygen in this compound is 2 to 5. But it said the actual mass was 236.04, okay? So actual molar mass is 236.04 grams per mole. So what I'm going to do is I'm going to take the mass of this to start. So I've got 2 N's and I've got 5 O's. Okay, so each N is 14.01. That's 28.02. And each oxygen is 16, 16, 16, 16, 16 times 5 would be 90. And so if I add those two numbers together, I find out the mass of this is 118.02 grams. Now what we want to do is compare it to this and see how many times larger is this. All right. So if I took 236.04 and divide it by 118.02, I'll see that that comes out to be 2. So the real molar mass is just 2 times as big as this. All right. So in order to get the actual molecular formula, I'm just going to 2 times everything, right? So instead of there being a subscript of 2, it's 2 times 2 is 4. Instead of a subscript of 5, it's 2 times 5 for a subscript of 10. And that's how you go from the empirical formula to the molecular formula.